All right. So we are doing chapter 10 now. There are two parts in this chapter, and I think this is a relatively easy chapter, so I think we can do it entirely online. Right. The first part of the chapter 10 is about HCF and LCM, the highest common factor and the least common multiple. All right. Now we learned that in primary school. In primary school, we try to find the HCF between 18 and 24, right? For example. Now in primary school, we did it like that. We try to find a common factor that you can divide both numbers. Say you can divide it by 6. All right. So remains 3 and 4. Until now, there's no more common factors between 3 and 4, so we just stop here. As for the HCF, that would be this 6, alright, that would be the 6. As for the LCM, that would be the product between all these numbers, 6, 3, 4, alright, so it's 6 times 3 times 4, and that amounts to 72. Alright, so that's how we do that in primary school. Another example, when the numbers are larger, say 120 and 225, alright, 225 and 140. 120, I'm sorry. Now, we did it in a similar way. We get a common factor that we can divide both numbers. Say, you divide it by 5. You have 24 and 45. Alright? And furthermore, you can divide it by, let's see. Okay, we can divide it by 3, for example. That remains 8 and 15. Alright, now there's no more common factors between 8 and 15, so we conclude that these two multiplied together will be the HCF, so that is 5 times 3 is 15. As for the LCM, that would be the product of all these numbers, so that is 5 times 3 times 8 times 15, alright, and that amounts to 1,800. So these are what we do in primary school. Alright. But I don't know whether you learned that in primary school, but there is another method called the method of prime factorization that we can also do it like this. It's called prime factorization. We try to factorize all these black numbers into prime factors. Say, for example, 18 will be factorized into 2 times 3 times 3. Alright, all these 2's and 3's, they are prime numbers. Likewise, 24 will be 2 times 2 times 2 times 3. Now, to put that in index notation, that would be 2 times 3 squared. And that would be 2 cubed times 3. Alright? And, well, for easier indication, maybe we can put back the power 1. Alright? So now you see 18 is 2 to the first power times 3 to the second power. 24 will be 2 thirds times 3, alright? Okay, now so from this little table here, we can determine what are the HCF and the LCM from this table. Alright. Okay, so it's pretty straightforward. For the HCF, now the highest common factor, you collect the lowest term. So this is the lowest power on this column. Alright? And that would be the lowest power on this column. Alright? On this column, the 2 to the first power is the smallest. On this column, 3 to the first power is the smallest. Alright? So we choose the smallest power on each column. So that is 2 to the first power, 3 to the first power. Alright, and that would be a 6. For LCM, on the contrary, the least common multiple, we choose the opposite. We choose the highest power. We choose the highest power in each of these columns. So we have 2 to the third power multiplied to 3 squared. So 9 times 8 amounts to 72. Alright. So that are the same answer as we obtained originally. Alright. So you see, this is what we call the method of prime factorization. Alright, so over onto the next page, I do the same thing for the two numbers. For 120 and 225, right? I'll make it quick. 120 will be 2 cubed times 3 times 5. Alright, put back the 1 power. Alright, and 225 will be 3 squared times 5 squared. Now notice, all the numbers with the same base, they are put in the same column, right? Base 3 in the same column. Likewise, base 5 in the same column. Okay. Now there's a missing 2 here. When there's no 2, that means it's a 1. Alright, there's a 1. So 1 is 2 to the power 0. 0. Alright. Okay, so once you can do the prime factorization, we can get the HCF and the LCM from this table. So the HCF, once again, highest common factor. You choose the smallest in each column. You choose the smallest power in each column. So this one, and this one. So that means the HCF will be 2 to the 0 power, 3 to the first power, 5 to the first power. And that amounts to 15. Alright. And likewise, the LCM, the least common multiple, you choose the highest power in each case. So we choose this one, and this one. So we have 2 cube, 3 square, and 5 square. And that amounts to exactly what we had before, 1,800. Alright, so that's about HCF and LCM for integers. Alright, now I try to talk about 2 different methods. One is the first method about using division. Alright, this one is called the Euclidean algorithm. Alright, in the next video, we are going to look at part 2 when we have the in addition to the numbers, when we have polynomials, how to do the HCF and LCM. So stay tuned for the next part.